Hey everybody, I hope that you are doing well and that you are finding some time to work on math. If you feel at any time that this is overwhelming for you or you have specific questions, you are always welcome and encouraged to send me a message. We can even Google chat or whatever you kids call it, I don't even know. But just let me know if you need some help. I'm happy to provide assistance if I can. All right, anyway, Chapter 7b is all about solving trigonometric equations. We'll take a look at some ideas from our unit circle. We'll include factoring as ways to solve for angle measures on the circle. We'll start off with some ideas that we know are familiar. If we have sine, cosine, and tangent, and we are asked to figure out the angle that matches that value, we're just working backwards. And we've done this before. Our first example says sine of theta equals negative radical 3 over 2. Remember, sine is the y coordinate. And if you use your circle as a guide, you know you have two answers for theta. Sine will equal negative radical 3 over 2 in two spots. It's the y coordinate, so it's negative. It'll be down at 240 degrees or at 300 degrees. If we were working with radians, we would do the same thing, but we would say 4 pi over 3 or 5 pi over 3. If you recall this from Chapter 6, this was like the last thing we did on the unit circle test. We're just working backwards. See if you can determine the answer for cosine of theta equals 0. What are the two values in degrees and radians? And then press play and see if we get a match. Okay, how did you do? Cosine is the x-coordinate on the unit circle. When x equals 0, you're either at 90 or 270 in degree form, or pi over 2 and 3 pi over 2 in radian form. All right, let's try one more tangent, or let's try one more value from the unit circle. When will tangent equal negative 1? Now this is a little bit more challenging, but hopefully we remember kind of utilizing some of those tangent tools. Tangent is y divided by x. And when you want that to equal 1 or negative 1, that means x and y have to be the same coordinates. One would just be positive and one would be negative. That's usually going to be in the middle of each of the quadrants. To get negative 1, if we were at 135 degrees and we did y over x, the y and the x fraction would cancel out and we'd be left with negative 1. And if we go in the opposite quadrant at 315, same idea. There we go. In radians, you'd be at 3 pi over 4 or 7 pi over 4. Like so. Now, when we say we're working backwards actually means we're taking the inverse of the function. So working backwards means we're taking the inverse. That's different than reciprocal. And the inverse is what's going to help us find values on our unit circle other than our 16 specific locations. Down below, we're going to have kind of a definition or template to follow using our calculator to simplify instead of the unit circle. We'll start with sine. When you have sine values, what you want to do to find your angle is take the inverse. And an inverse is found by using that negative 1 button. And then you'll have something on the inside that you're taking the inverse of, whether it's negative square root 3 over 2, 1/2, or possibly a decimal. That will give you one answer. For the second answer, we have a formula to follow. It's not quite as easy as using the unit circle to find the ordered pair, but we use the idea of the unit circle. So for that second answer, what we'll do is we'll take 180 degrees minus our angle that we found by taking the inverse. In radians, we'll do the same idea, but in radian mode, 180 degrees is equivalent to, and I don't know why I keep getting the highlighter, there we go, is equivalent to pi minus theta. That will always give you your second answer when you're using sine. Cosine is a little bit different, but the same kind of process. If you get the trig value or the fraction by itself and it's not on the unit circle, you'll take the inverse on your calculator, that little negative 1 button. And in degrees, what you'll do is you'll then take 360 minus your theta, or in radians, that would be 2 pi. It's going to be significant to note what mode you should be in on your calculator. Tangent's the only one that will have addition. For tangent, if you're finding a value that's not specific to our unit circle, you'll take the inverse on your calculator. And then for that second angle, what you'll do for tangent is you'll take 180, but then you'll add your angle to that. Or in radians, you'll take pi and then add your radian measure. You will for sure want to know these 3 definitions on how to get that second angle for your solution. These definitions are true for all of our exact values on the unit circle and our approximate values for all of our angles theta. When solving, your restrictions are always going to be between 0 and either 360 or 2 pi. Here are some things to keep in mind. You're always going to take the inverse on your calculator. And remember, that's that -1 button, and that's going to be different than reciprocals. Your answer must be positive. So what happens if you get a negative answer on your calculator, because you will from time to time, you're going to want to make it coterminal. We haven't seen that in a long time, but to make something coterminal, what you want to do is either add 360 in degrees or 2 pi in radians to that, and it should make your answer positive. One final thing to note is if we keep this restriction up above, notice your answer cannot actually equal 360 or 2 pi, and it cannot be greater than that value. There'll be lots of things to consider when we solve in this lesson. Now, to remember your types of answers, if the restriction in the direction says this, we know that that last number means you're going to be in degree mode. You'll want to make sure that you do that on your calculator before you start solving. And if the restriction in the directions says from 0 to 2 pi, you would want to make sure to convert your calculator to radian mode. Definitely do that before you start. All right, make sure you have a calculator handy, and then try these with me. Try typing them in on your calculator to make sure we get a match. The directions say solve for values of theta between 0 and 360. That's going to indicate degree mode in your calculator. So for sure, test that or check that before we even start. It says give approximate solutions to the nearest tenth of a degree. So we're going to want to be mindful of our directions and give the answer in the correct form. Now it says sine of theta equals 0.43. If we think about values on our calculator, that's not one, or on our unit circle, that's not 1/2, it's not square root 3/2, it's not even square root 2/2. It's an approximated location. What we'll do then to get theta by itself is we'll take what's called the inverse of the opposite side, 0.43. That's how you would write it out. And then on your calculator, you'll have to hit the second or shift function, and then right above the sign button, there's a sign with a -1. That's your inverse. If you type that in and press enter, you should get a degree measure of approximately 25.5 degrees to the nearest tenth. That's in quadrant 1. That's one answer that would be valid for sine equaling about 0.43. To get your second answer, remember we subtract that one from 180. And you'll be responsible for writing both solutions when necessary. If we take 180 minus 25.5, we get 154.5 degrees. That would be our second answer. So thinking about what this actually means on our circle, if we visualize our circle, we know that 25.5 degrees would be somewhere in quadrant 1, a little bit lower than that 30-degree mark. But 154.5 would be all the way over in quadrant 2, kind of at that same height. So the distance away from x on each side is going, to the x-axis, on each side would be the same. That's kind of the purpose behind finding both solutions. All right, let's try the next one. Now it says tangent of theta is negative 0.8. Thinking about when tangent is negative, we know that that's in quadrants 2 and 4. So our answers need to be degree measures that fit that criteria. In degree mode, let's make sure to type in our inverse for tangent. And we have negative 0.8. Type in tan inverse of negative 0.8. And what ends up happening here is we get a negative answer. We get negative 38.7 degrees. If we think about the right-hand side of the x-axis and what that means we're rotating clockwise. And that would technically put us into quadrant 4, which makes sense because tangent is negative in quadrant 4. But according to our restrictions, we can't have a negative answer. So remember what we said on the other side. If you have a negative measure, make it coterminal. What that means is I'm just going to quickly add 360 to this original value. And negative 38.7 plus 360 would be 321.3 degrees. That's between 0 and positive 360, and it's in quadrant 4. So that would be when tangent is negative. Here's the kind of unique part for these negative values. To get your second answer, you're going to use that negative measure. Our second answer for tangent is 180 plus theta, but we're going to do the original theta, not the coterminal theta. And if you take 180 plus negative 38.7, ultimately you're subtracting, that's going to give you 141.3 degrees. And check that out. That's in quadrant 2, and we all know that quadrant 2 is when tangent is positive. Our two solutions then are 321.3 and 141.3 degrees. All right, let's try one more. Let's try tangent, or cosine. Let's try cosine. Cosine of theta equals 1/3. 1/3 is a fraction, but not one of our specific unit circle friendly fractions. That means we'll take the inverse on our calculator. And just write this process out each time. Your homework will be just like this. It should be pretty straightforward to follow, I hope. Now, cosine would be positive in quadrant 1 and in quadrant 4. That means our answers need to match accordingly. If we take cosine inverse of 1/3 to the nearest tenth, we get 70.5 degrees. And that's in quadrant 1. We're in great shape there. But remember, it can also be positive in quadrant 4. We'll use our formula to get that second answer. For cosine, it's 360 minus whatever we got for that first answer, 70.5. Our second angle would be 289.5 degrees. And that is, in fact, in quadrant 4. This is solving equations when we're in degree mode. You had to know that reciprocals were going to be in this mix as well. When we solve for secant, cosecant, or cotangent, what you want to do is isolate the trig term first. Make sure that those terms are by themselves on one side. But then you're going to take the reciprocal before you plug it into your calculator. So the reciprocal is different than the inverse. Here's what I mean by that. Solving between 0 and 360, again, we're in degree mode, so we're good to go there. We're already in degree mode. And we'll do nearest tenth of degree again. Okay, so it's business as usual. That first example has secant of theta equaling 2.5. Well, secant isn't an inverse on our calculator, but its reciprocal is. Here's what we do. We don't write the definition for secant. We're not going to write it as 1 over cosine. We're just going to take the reciprocal of each side. The reciprocal of secant is cosine. And the reciprocal of 2.5 is 1 over 2.5. That's all you have to do. And now we'll take the inverse using cosine. That's user-friendly on our calculator. Once you have cosine isolated, we'll take its inverse. And we're just going to take the inverse of the fraction. When you enter this in on your calculator, make sure that that's in parentheses, and you should be okay. Remember, to the nearest tenth, cosine inverse is approximately 66.4 degrees. There's answer 1. The rule for cosine answer 2, subtract it from 360. and that will put it down in quadrant 4. 360 minus 66.4 is approximately 293.6. There are your two answers for secant of theta equaling 2.5. Our next example, cotangent theta minus 3 equals 0. Well, if the minus 3 is on the left, move it over to the right by adding it. Like so. That isolates our cotangent term. Cotangent of theta equals 3. Now remember, take the reciprocal on the left. The reciprocal of cotangent is tangent. Take the reciprocal on the right. The reciprocal of 3 is 1/3. Now take the inverse. To take inverse for tan, that's not what I meant to say. To find theta, oh, this is going to be a long thing, you guys. To find theta, take tan inverse of 1/3, and that's a tiny answer. It's approximately 18.4 degrees. Definitely in quadrant 1 where tangent's positive. To get the second answer for tangent, the formula is 180 plus theta. And if we add 18.4 to 180, we'll be down in quadrant 3 where tangent's also positive, 198.4 degrees. And there are your two solutions for cotangent theta minus 3 equals 0. All right, last but not least, we had to throw a cosecant in there. If I subtract 4, we get negative cosecant theta equals positive 3. Now remember, you want to isolate your trig term. That means I'm going to move the negative by dividing each side by -1. And that will isolate our trig term. And we get -3 on the right. Now the reciprocal of cosecant is sine. And the reciprocal of -3 is -1/3. All right, now that we have our traditional kind of basic trig function, take its inverse. And some of you may already be thinking, if we have a negative, it might give us a unique answer. And it does. If we take sine inverse of -1/3, we're going to get negative 19.5 degrees. We always want to make a negative answer coterminal so that it fits the criteria for our restriction in the directions. I'm going to add 360 to that right away to make it coterminal. Negative 19.5 plus 360 would equal 340.5. We know that tangent's negative in quadrant 4, and that's an angle that would give us that negative, an angle that would give us that negative solution. All right, last one. Remember, we take this answer to figure out our second solution. If we do 180 minus that answer, we get a double negative, and that would change to positive. 180 plus 19.5 would be 199.5. That's down in quadrant 3, where sine is also negative. This is a big video lesson to start us off, you guys. This is all we're going to do for today. So all you need to do is take a snapshot of the notes and send them to me via the assignment on Schoology for your credit.